All right, so if you can turn to page 22 in your packet, today we're going to take a look at something called shifts, or another word for this would be transformations. All right, so if we look at number 37, we're given this function, y equals x squared. Okay, this is just your basic parabola. And it says underneath it, describe how the original graph would change if the function was changed to this. Now, if you notice the difference between these two equations, right? This is y equals x squared. This one is f of x equals x squared plus 2. So for this one, we're adding a 2 to the end of the function. Okay, so what I'm going to do is I'm going to go to y equals in my calculator, and I'm going to plug this new equation in, and we're going to take a look at the graph and see how its graph compares to the original function. Okay. All right, so this is what our new graph looks like. Now, if we compare this to the original, what you'll notice is it's the same thing, but it's just shifted up 2 units, right? This one through the vertex was at 0, 0. Here, our vertex is at 0, 2. So when you add a number to the end of a function, basically it's going to shift your function up. All right, so there we go. All right, now if we take a look at letter B. Letter B, we have a minus 2 at the end of the function. Now, I'm sure you guys can take a guess at what this might do, but let's just plug this in our calculator and graph it, just so we can be sure. All right, so here we have it. Here's the picture of f of x equals x squared minus 2. Now, look at this function and look at the original function. So what happens when we subtract a number from the end of a function? It's going to shift it down that many units. So in this case, 2 units. Okay, now let's look at what happens when we add or subtract a number within the function. So what I mean by that, see how this says y equals x squared, the original function? What we did is instead of just squaring the x, we took 2 and added it to the x and then squared it. Over here, we subtracted 2 from the x, and then we squared it, okay? So let's look at what happens when you add or subtract a number within the function itself, in this case, within the parentheses. Okay, so what I did was I plugged this in my calculator, I went to y equals, and this, when I hit graph, is what we see. Okay, now what you'll notice is that, again, the original function had the vertex at 0, 0. This, the vertex is at 0, negative 2. When you add a number within a function, it actually moves it that many units to the left. Okay, so again, if you add a number within the function, it shifts your unit to the left. It's kind of, you're like, wait, that's the opposite of what I'm thinking, because when you shift to the left, you're shifting in the negative direction. So this has the opposite sign of what you would think. Let me just show you why. Within the parentheses, it's really x minus your shift. So if we're doing x minus and we shifted 2 units to the left, so x minus negative 2, right? If you're shifting to the left, you're going in the negative direction. Isn't a minus negative a positive? And that's how we get the plus sign within the parentheses. So anyway, it's just the opposite sign of what you would think. If there's a plus sign in the parentheses, you're moving to the left. So if you look over here, what do you think is going to happen if we have a minus sign in the parentheses? Which way do you think it's going to shift? All right, well, here's our graph of f of x equals x minus 2 squared. So which way did it shift? If you said to the right, you are correct. Okay, so just to clear this up, if you add a number to the end of a function, it shifts it up. If you subtract a number from the end of a function, it shifts it down. If you add a number within the function, it shifts it to the left. And if you subtract a number within the function, it shifts it to the right. Okay, now if you look at the bottom of the page, I kind of just put the original function from the top right over here on the right, just so we could see it. Okay, now, what they're doing here is they're putting a negative in front of the function. They're negating the function. All right, so let's plug this in our calculator and see what happens. Okay, so when we put a negative in front of our function, right, f of x equals negative x squared, this is what we get. So if you look at your original function, basically what we did was, see the x-axis right here? We took our graph and we reflected it over the x-axis. So all of these points, right, 1, 1 became 1, negative 1. 2, 4 became 2, negative 4. Okay, this graph was reflected over the x-axis. Okay, so if you can turn to the next page, page 23. Okay, so at the top of the page, they just sum up the rules that talk about shifting something up, down, left, and right. Remember, if you add a number to the end of a function, it shifts it up. If you subtract a number from the end of a function, it shifts it down. If you add a number within the function, it shifts it to the left. And if you subtract a number within the function, it shifts it to the right. Okay, so that being said, number 8, if you could just hit pause and try this on your own, you're just going to write either up, down, left, or right, okay, whichever way the graph is being shifted. All right, so let's see how you did. All right, so in letter A, since we're adding 3 within the function, that is going to shift it 3 units to the left. All right, so let's put left on that line. Okay, letter B. And when we look at this one, look at what they're doing. They're adding 3 to the end of the function. So if you're adding a number to the end of the function, like we did here, it's going to move it up. Okay, in letter C, we're subtracting a number from the end of a function. So when we do that, it's going to move it down. Okay, and then finally, letter D. Here you could see we're subtracting a number within the function. So if you're subtracting within the function, it's shifting it to the right. Okay, so number 39, it says relative to the graph of y equals the absolute value of x, what is the shift of each one of these graphs here? Now, you could go to y equals and plug this in your calculator, and we can again examine what happens, but let's just use our rules here to do this. Okay, so here you could see in letter A, we're subtracting a number within the function, right? We're doing it within the absolute value bars. All right, so everyone hit pause and take a minute and write down which way that's going to shift it. All right, so if you said to the right 5 units, you are correct. All right, let's go over here to letter B. So in letter B, we're adding 4 to the outside of the function. So again, hit pause, write down which way, that's going to shift it. All right, so if you said 4 units up, you are correct. All right, now look at letter C. In letter C, they put a negative in front of the absolute value bar. Okay, so they're negating the function. So think about what that does. All right, so if you said a reflection over the x-axis, very good job. That's exactly what it does. All right, let's look over here at letter D. So in letter D, we're adding 3 within the function. So everyone hit pause and write down what that does. All right, so that is going to shift to the left, right? That's shifting it 3 units to the left because we're adding a number within the function. Okay, now if you look at letter E and letter F, there's actually more than one thing going on. So here we see we have in letter E 2 transformations happening. So if you could hit pause and write down what those are, then you could hit play and see how you did. All right, so the +7 within the function tells us we're going 7 units left, and the -43 from the end tells us we're going 43 units down. All right, and finally, letter F. All right, here we have 3 things going on. So hit pause and see if you could write what each one of those represents. Okay, so here we have it. The negative tells us that we have a reflection over the x-axis, and then that's followed by this -1 within the function tells us we're shifting it 1 unit to the right. And then this plus 9 at the end of the function tells us that we're shifting it 9 units up.